A sine wave is a smooth, repetitive waveform. One completion of the repeating wave pattern is called a cycle. The time it takes to complete one cycle of the wave is called the period. In this example, the time it takes to complete one cycle is 0.25 seconds. So this waveform has a period of 0.25 seconds. The unit of measurement of wave frequency is called hertz. A hertz is equal to the number of wave cycles occurring in 1 second. For this wave, there are 4 cycles in 1 second. Given that frequency is 1/t, or period, then the frequency is 4 cycles in 1 second, or 4 hertz. The highest point or the lowest point of an AC waveform are referred to as peaks. Peak amplitudes or values can be measured in the positive direction starting from the baseline or in the negative direction. The peak-to-peak value is measured from the negative aspect of the waveform to the positive aspect. In symmetrical waveforms, the peak-to-peak value is twice the peak value. AC meters generally do not read in peak values or peak-to-peak values, whether it is voltage or current. AC meters will read in root mean square or RMS values, also referred to as effective values. If the DC is set at 10 volts, this will produce a certain amount of power and heat in the resistor. If you regulate the AC input in the AC circuit until you reach the same amount of power and heat, it will require 14.14 volts peak to be as effective as the 10 volts required in the DC circuit. This is due to the alternating characteristic of an AC wave whereby voltage oscillates between peak-to-peak maximum values. Thus, on average, full voltage is not being continuously delivered to the AC circuit to generate the same power as a DC circuit. Therefore, to compensate, AC circuits need higher voltage input. When the power in the DC matches the power you produce in the AC voltage of 14.14 volts at its peak is as effective in producing the same power as 10 volts in a DC circuit. Therefore, we can define the AC peak value as 1.414 times 10 volts or 10 RMS, which equals 14.14 volts. You may also want to determine the RMS by dividing the AC peak value of 14.14 volts by 1.414 to get 10 volts or 10 RMS. Therefore, an AC voltmeter connected across the resistor in the AC circuit would read 10 volts.